Hello everyone, and now we are going to record the mistakes of my test 2, chemistry test 2, where I scored 153 out of 200 and the highest was of 170 out of 200. So first question I was wrong with is, which one of the following groupings represents a collection of isoelectronic species? Now see, isoelectronic species are the species with the same electronic configuration. So A option, Na plus, Ca2 plus and Mg2 plus. No. Now see, Na plus means 10 electrons, Ca2 plus means 18 electrons, Mg2 plus means 10 electrons. So these are not isoelectronic. A option is wrong. B option, Na minus 3, F minus 1 and Na plus 1. So Na minus 3 means what? 7 plus 3, 10 electrons. F minus 1 means 9 plus 1, 10 electrons again, and then Na plus 1 means again 10 electrons. So B option is right answer. They are isoelectronic species. C option says Be plus 2, Al3 plus Cl minus 1. So Be plus 2 means what? 4 plus 4 minus 2, that is 2. Al plus 3 means what? It will be like, see, B will have 2 electrons, Al will have 10 electrons, Cl will have 18 electrons. So they are not totally different electronic configuration. And the option Ca2 and Cs and Br are very different. No, like Cs is of cesium is 55th and bromine is 35th. So it's like Zameen Asman ka farak. Then so option B is right answer, right? Then okay, so yeah, this question I was wrong with. Which one of the following sets of ions represents a collection of isoelectronic species? So K plus, Cl minus, Ca2 plus, Sc3 plus. Now see, K plus means what? Potassium is 19. It will give 1 electron. It will have 18 electrons. So Cl minus means 18 again. Ca2 plus means 18 again. And scandium 3 plus, which is 21st, which will again 18. So A option is right, they are isoelectronic. B option, Be2 plus means what? Barium. Barium is 56th element and it will lose 2 electrons. It will have 54 electrons. Strontium is 38th element. It will lose 2 electrons and it will be like 36. Potassium will lose 1 electron, it will attain 18, and sulfur will lose 2 electrons, it will take 2 electrons and it will get 18 electrons. So they are not isoelectronic. C option, N3 minus, O2 minus, S minus, S2 minus. Now see, N3 minus means what? 7 plus 3, 10. O2 minus means what? 8 plus 2, 10. Yes. F minus 9 plus 1, 10. S2 minus means what? 16 plus 2, 10. 16 plus 2, 18. So C option is also wrong because of sulfur 2 minus. D option, Li plus, Na plus, Mg2 plus, Ca2 plus. Now see, Li plus will get 2 electrons. Na plus will get 10 electrons. Mg2 plus will get 10 electrons. Ca2 plus will get 18 electrons. So they are totally wrong. They are not isoelectronic. So option A is right answer. Then now see, 15th question says that the frequency of light emitted for transition n is equal to 4 to n is equal to 2 of helium plus is equal to the transition in H atom corresponding to which of the following? So we have to frequency of light emitted. Okay, so it is equal to what? So we have to use the Rydberg formula, that is 1 upon lambda is equal to Rz square 1 upon n initial square minus 1 upon n final square. So there we get the answer as B option, n is equal to 2 to n is equal to 1. Here the question was wrong, so we had got extra 4 marks for this. Yeah, right. So we have to calculate it with the Rydberg formula method. 17. The maximum energy is possessed by an electron when it is present. Actually, the right answer is that at infinite distance from the nucleus, that is not in the ground state. I had attempted it as B option, ground state, but it is wrong. D option is the right answer for this question. The maximum energy is possessed by an electron when it is present at the infinite distance from the nucleus, because it will have the maximum, it will have, like, wait 2 minutes, I'll just read the statements which were given by our answer. Just let me just check it out. 2 minutes. Okay. See, on increasing radius, total energy increases, right? See, on increasing radius, total energy increases. On increasing radius, potential energy also increases. And on increasing radius, kinetic energy decreases. On increasing radius, total energy increases. On increasing radius, potential energy also increases, but on increasing radius, kinetic energy decreases, right? So they have asked the question on the maximum energy, so total energy. So of course, when the electron will be at the infinite distance, it will have the maximum energy. So at the infinite distance from the nucleus, this is the right option, is D option. Now, the nodes present in 3p orbitals are, now see, node is a space where electrons are not there. The electron density is 0. Now see, option is 1 spherical, 1 planar, 2 spherical, 2 planar and 1 planar. Now see, they have asked that 1 spherical, 1 planar. Now see, just remember, planar node is the angular node. There are two types of node, angular node and radial node. Angular node and radial node. Planar node means what? It is called as angular node, which is represented by L. L is the AQN, and azimuthal quantum number, right? AQN, azimuthal quantum number. AQN, azimuthal quantum number. Spherical node is the radial node, which is represented as N minus L minus 1. N minus L minus 1. So see, 3p. So 3 sp. So 3c. Now L of this orbital, 3p orbital, will be what? 2. L will be 2. So angular node will be 2. And spherical node will be 3 minus 2 minus 1. That is, wait. Am I going something wrong? Wait. Just check it. Yeah, sorry. Actually, I made a mistake. I was not remembering. Now see, just remember that we represent orbitals as azimuthal orbitals as SPDF. S is 0, P1, D is 2, and F is 3. SPD, F0, 1, 2, 3. Right. So now angular node, that is planar node. Angular node, that is planar node. For angular node, that is planar node, for 3p orbital will be 1, because 3p and angular node is L. So p orbital has 1 as the azimuthal quantum number. Value of L for the p orbital is 1. So angular node is 1. Spherical node will be n minus L minus 1, that is 3 minus 1 minus 1, that is 3 minus 2, that is 1. So the right option for this question, 20th question, the nodes present in 3p orbitals is 1 spherical and 1 planar. Spherical node is radial node and planar node is angular node, right? Then 23rd, the uncertainty in momentum of an electron is 1 into 10 raised to minus 5 kilogram meter per second. The uncertainty in whatever. Okay, so here we have to use the formula of Heisenberg's uncertainty principle, that is lambda is equal to h upon 4 pi mv, right? They have given the value of momentum, that is mv. So it is easy. H upon 4 pi mv means what? H is 6.6 into 10 raised to minus 34 upon 4 pi. 4 into 3.14 into 10 raised, into given value of mv, that is momentum, that is given as 10 raised to minus 5, right? So the option will be C option. It was a silly mistake of mine, I had calculated it, but I had not marked in the answer sheet only. So this was very silliest one. 32 question says that non-directional orbital is. Now remember, it is 3s. S is directional orbital. 3s is like, why it is non-directional orbital, s orbital? Because s orbital has a shape of spherical shape. So we cannot assume the electron density at an accurate point. It is like without directions. So it is considered as non-direction, right? Then according to Bohr principle, the correct order of energy of 3d, 4s and 4p orbitals are. Now see, 3d will be, energy of 3d will be 3 plus 2, 5. 4s will have 4 plus 0, 4. And 4p will have 4 plus 1, 5. Now, the greater energy will be of 4p first. 4p will have the greater energy. And then will be the 3d. And then the least energy will be of the 4s. Yes. So C option is right in this question. The number of unpaired electrons in Fe3+. Now see, this is the question of ionic electronic configuration. So ions are present. So what happens that actually Fe has the configuration as 4s1 3d10. Sorry, it's not like that. 4s1 3d is 6 because ion is 26, right? So 4s2 3d 6. 4s2 3d 6. Now three electrons are lost. They are given out. So it will become 4s2 3d3, right? 4s2 3d3. Now d orbital has become unstable. Like d orbital has the capacity of holding minimum half filled 5 electrons and maximum full filled 10 electrons. But now it is having only 3 electrons. So now what happens? The 2 electrons in 4s orbital will get transferred into the 3d orbitals. And it will add up in 3d. So it will become 4s0, 3d5. So the electronic configuration of Fe3 plus ion will be 4s0, 3d5. And so the number of unpaired electrons in Fe3 plus is 5. Actually it must be 7, but unpaired electrons is asked in the valence shell, I guess. So it is the answer as 5. Now, the charge to mass ratio of alpha particle is approximately the charge to mass ratio of protons. Now see, alpha particles have charge as, I guess, okay, charge to mass ratio of alpha particle is approximately, charge to mass ratio means see, alpha particle has the charge as plus 2. Wait, is it plus 2? Just let me remember what had I done in it. So the charge to mass ratio of alpha particle is approximately half the charge to mass ratio. Okay. So charge on the alpha particle is, I guess it will be plus 2 and the mass will be plus 4. Of charge of protons, I guess charge will be plus 1 and mass is also plus 1. So it is 1 by 2. So alpha upon proton. So charge of the mass ratio half of the charge of the mass of the proton. Yes, right. So C option is the right answer because charge of alpha particle is plus 2 and mass is plus 4. So charge to mass ratio will be 2 by 4, that is 1:2. Yes, right. So C option is right one. The two electrons in K subshell will differ in. Two electrons in K subshell will differ in, of course, spin quantum number, because yes, because every electron has different spin quantum number. It can be clockwise or anti-clockwise. Not principal quantum number. Principal quantum number will be same, that is 1, right? And azimuthal quantum number in K subshell. Now see, K subshell has only 2 electrons, right? So 2 electrons are attained in s orbital. So s is the so azimuthal quantum number will also be the same. Magnetic quantum number. Now this I have to think on it, like magnetic quantum number, because I guess it will not be the right answer. Spin quantum number is the accurate answer. Dual nature of particles was proposed by de Broglie, right? Heisenberg had given uncertainty principle, and Schrodinger's wave equation was there. Electron density of the orbitals, right? 42 question gives that p orbitals of an atom in the presence of magnetic field are. P orbitals in the presence of magnetic field are, of course, or they are non-degenerate, means they do not have the same energy, right? They do not have the same energy in the presence of magnetic field. In the presence of magnetic field, remember, in the presence of magnetic field, they are non-degenerate. 45th is the maximum energy is possessed by an electron when it is at the infinite distance from the nucleus. Now 47th is number of unpaired electrons in Fe3+ is 5 in valence shell, okay? Remember. I've completed with the mistakes and I had scored 153 out of 200 in this test.